Where does the universe hide the secrets that might tell us how to travel in time? Our exploration has taken us through the world of wormholes and their possibilities as time machines. And now we're in search of the technology that might make space travel and time travel two sides of the same coin. If there's nothing on Earth that comes close to being a time machine now, there is something that might one day lead us to new laws of physics that help us determine if it's at least possible. It explores the universe not in the realm of the cosmic web and its galaxies, but in the domain of quantum physics, involving particles at sizes more than 1,000,000 times smaller than the smallest atom. It's the newest tool at the frontier of physics called the Large Hadron Collider.
The Large Hadron Collider is the largest, most complicated machine ever created by humankind. And its role is to help us study the frontier of particle physics. What it actually does is it accelerates protons in two directions around the ring, one way round and the other way round, to nearly the speed of light, and then collides them.
The collider went operational in November 2009. And as scientists ramped up the power, the energy in its collisions was increased almost tenfold by March 2010. And it will double that sometime after 2013. Today's theories of space, time, gravity, and quantum physics are still incomplete. And tools like the Large Hadron Collider will help fill in the ever-puzzling blanks.
This is where we expect that if there's some missing physics that we need to understand space-time in a way that will tell us whether time travel is possible or restricted in various ways, this is where we expect the new results to come from.
The goal is to figure out how rules governing the tiniest particles in existence also apply to the biggest things like stars, galaxies, and the expanding universe itself. Without understanding this, building a time machine might be harder than trying to build a radio without knowing about the existence of electricity.
There are many physicists in the world who believe that this understanding is in fact right around the corner, that it could happen within a few years or a few decades. On the other hand, it could be that this problem is in fact much harder than we think, and that human civilization will simply not live long enough to figure out how it works.
The Large Hadron Collider might also reveal extra dimensions that could play a role in time travel. We live in 3 dimensions of space. If we lived in only 2 dimensions, our universe would be a flat sheet. A sphere would look like a circle to us. The 3rd dimension would be there, but just hidden from our view. If dimensions other than our familiar 3 are really there, they too are hidden.
If we were to find experimental evidence for the existence of other dimensions, and if we were to be able to explore the meaning of these other dimensions and see how they come about, it could be that far, far in the future, this new physics would be utilized to come up with some new form of travel that allows us to at least get close to the speed of light barrier, if not surpass it.
Getting close to light speed may be the most promising way to travel in time by slowing down our clocks. In this respect, the Large Hadron Collider is leading the way, even if its first step is an extremely small one.
The Large Hadron Collider is 17 miles around, and it accelerates protons to nearly the speed of light. If you wanted to do that, but with human beings, a rough calculation shows you'd have to scale it up to 1,000 light years around in order to do the same thing.
This is like saying that the spacecraft powerful enough to carry us to the stars at that speed would be bigger than the distance we need to travel. Big enough, in fact, to enclose the nearest 100,000 stars.